I discussed big numbers before when we were talking about primes, so now I'd like to make just a few more small points. As you know, 10 to the 6 is a million, 10 to the 9 is a billion, and 10 to the 12 is a trillion. In other words, 1 followed by 12 zeros. A googol is 1 followed by 100 zeros, or 10 to the 100, and a googolplex is 10 to the googol, which is then 10 raised to the power 10 to the 100. So it's 1 followed by a googol of zeros. Now, just as an aside, there is a connection between Google and Google, the search engine. The word Google was coined by the 9-year-old nephew of one of the authors, Edward Kasner, of the book Mathematics and the Imagination, first edition 1940. It's quite a wonderful book actually, and it's available at archive.org. The context is that Kasner asked his nephew for a name, suggested name for this number, and the nephew gave the name Google, and then suggested googolplex for 1 followed by a googol of zeros. The search engine Google, Google, was initially meant to be Googol, but a typing error was made somewhere along the line, and as a result, the two founders of Google stuck with the name Google, Google. Okay, so we also mentioned before that the number of atoms in the universe has been estimated to be 10 to the 80. Some other large numbers, 10 to the 22 is a rough estimate of the number of atoms in a grain of sand, and 10 to the 22 grains of sand on Earth, another estimate, very crude estimate. 10 to the 23 stars in the universe, so more stars in the universe than grains of sand on Earth, at least by these two estimates here. And this one I find a little surprising. If I take 60 books on one of my bookshelves, the number of ways of arranging them is 60 factorial, that's 60 by 59 by 58 by 57 and so on, all the way down to 1. But that comes out to be roughly 8.23 by 10 to the 81. So there are more ways of arranging books, 60 books on my bookshelf, it's not a particularly large number, than there are atoms in the universe. Another useful fact is that a natural number has m digits if and only if the number is bigger than or equal to 10 to the m minus 1 and less to the 10 to the m. For example, the smallest number with 3 digits is 100, so x has to be bigger than or equal to 10 squared, so we take m to be 3, and the largest number with 3 digits is 999, just less than 1,000. And similarly, you get this fact here, not just with m equals 3, but in general. And a consequence, and this is quite useful, is if I take two numbers x and y, say with 150 digits each, then when I multiply them, the product will actually have roughly 300. In fact, it'll be either 299 or 300 digits. So more generally, if I take the number x in this range, in other words, it has m digits, and a number y in the same range with replacing m by n, then their product will lie in the range, it'll be less than 10 to the m plus n, and bigger than or equal to, this is the product, and bigger than or equal to 10 to the m plus n minus 2, which is m plus n minus 1 minus 1. And that gives you this result here. You may like to write that out a little bit more carefully, but just think of the case of multiplying, say, a 2-digit number by another 2-digit number, or by a 3-digit number.